Assalamualaikum warahmatullahi wabarakatuh and very good morning. My name is Siti Binti Rashid, metro number S50797, and I will present about a review of fermented coconut Cocos nucifera as an enrichment for freshwater prawn microbrachium roseveji labriculture. My supervisor is Dr. Rasina Binti Rashid. Larvae of microbrachium roseveji is a free-swimming larvae in brackish water within 10 to 12 ppt. It undergoes 11 larvae stage and commonly they consume zooplankton, small worms, and larvae stage of other crustaceans. The estimated egg produced by a female broodstore is 5,000 until 10,000 depending on their size. The life cycle of freshwater prawn. The reason for choosing fermented coconut is because the price is affordable and easy to get. It also easily digests by prawn and rich in dietary fiber, carbohydrate, vitamins, and mineral. According to Puri 2011, coconut has a high nutrient content with calcium, water, crude protein, fat, carbohydrate, raw fiber, vitamin B1, vitamin B5, and vitamin C. Coconut also relatively large planting area and provided a lot of substantial benefit for economy and human life. Problem statement. First is high price of artemisias. Second is inadequate nutritional quality and production rate is not consistent. Objective for this review is to investigate the potential of using fermented coconut Cocos nucifera on growth and survival of freshwater prawn microbrachium roseveji larvae. The main material that I highlight is dried coconut flesh, which is copra meal, and filamentous fungi, which is Aspergillus niger. For the fermentation process, biotreatment of copra meal were chosen and solid state fermentation (SSF) were using for this fermentation process. This is the 7 journal that using fermented coconut with different method and different species, which is grouper fish, rabbit fish, black tiger shrimp, catfish, milkfish, catfish, and black tiger shrimp juvenile. The result for grouper fish for inclusion level is 30%. The method is using bioprocessing system, using solid state fermentation, employing the fungus Aspergillus niger. The effect on growth is enhanced growth rate and improved survival rate. For the rabbit fish, inclusion level is 40%, using a rhizopus species at 1 gram rhizopus per 1 kilogram copra meal. The effect on growth is enhanced high growth rate and improved maximum survival rate. For the catfish, inclusion level is 20%. It using the fermentation of coconut waste using bread yeast for 6 days. The effect on growth is the highest growth body weight. Effect on survival is higher survival rate. For the milkfish, inclusion level is 25% using isonitrogenous and isocaloric diet containing 0, 5, 10, 15, 20, and 25% of the locally produced fermented coconut. The effect on growth is better growth compared to the commercial milkfish feed. Effect on survival is high survival rate. For the carpfish, the inclusion level is 25%, using a rice bran coconut bagasse mixed with substrate fermented using Rhizopus oryzae. The effect on growth is commercial feed promote better growth than the fermented feeds. Effect on survival. Fermented feeds result in high survival rate considered with standard values of 80 to 90%, according to SNI 2015. For the black tiger shrimp, Penis monodon juvenile, inclusion level is 40% using fermented copra meal, biotreatment of copra meal solid state fermentation, enzyme produced by filamentous fungi such as Aspergillus niger. The effect on growth is particularly higher compared to non-fermented copra meal. For the effects on survival is much higher than the commercial feed. For the black tiger shrimp, The inclusion level is 40%. Using a 5 isonitrogenous diet, 41% crude protein were prepared with fermented copramyl progressively. The effect on growth is no negative effect on growth and height growth performance. For the effect on survival is height growth rate. According to the journal, it can discuss that grouper fish using a fermented coconut, efficient nutrient absorption that lead to improved fish growth. For the rabbit fish, fermentation using rhizospus species improve the quality of copra cake meal by increasing crude protein and some amino acids and reducing lipid levels. For the catfish, this proved that the addition of fermented coconut waste in feed affect the level survival rate of catfish and the mortality rate declines. For the milkfish, growth and feed conversion ratio of the fish fat, the fermented copramyl diet was significantly higher than the commercial control diet. For the carpfish, it promotes the high growth rate and slower rates in commercial feed. For the black tiger shrimp juvenile, it can discuss that fermented copramyl diet have equivalent protein quality, and for the black tiger shrimp, the quality of the amino acid of fermented copramyl is as good as that of fish meal, and fermented copramyl protein is efficiently utilized by the shrimp. In a conclusion, fermentation of copra can significantly improve nutrient digestibility of the ingredient when used in fish species requiring high amount of dietary protein. Fermentation of copra may also improve the nutrient content, resulting in increased crude protein and total amino acid levels. This is the reference. Thank you for your time.